Good morning, and for some of you, probably good afternoon. All right, we're going to start a new section today, so you need to get your books out and look at 9.2. It's a lot of math. In fact, it's going to be a lot of Pythagorean theorems, so pay attention because I'm going to put most of the problems on the board today, and then I'm sending you out a practice sheet so you can work on it. Again, you got to remember, follow the instructions because almost all the things that we do today are going to be on the test. Right now I'm thinking about having a test covering 9.1, 9.2, and 9.3, and I was just looking and it's not that hard. It's a lot harder than just giving an individual test. So let's go ahead and get your books out and we'll go over this, and then you're probably more interested in how to solve the problem. But go to page 574 in tangent theorem, and you probably want to have a 3x5 card or something else like that. But again, it says in the tangent theorem in the blue, it says a line that is tangent to a circle, then the line is perpendicular to the radius of the circle, to the circle drawn to that point of tangency. Okay, so tangent theorem is this. All right, so here is I'm going to put up my radius. Now, that point of tangency, right? That point of tangency forms a right angle. That's all they're saying. It says the radius drawn from the center to that point of tangency always forms a right angle. So that takes care of that one. But before I even go on, you notice I can use the Pythagorean theorem if I connected these, didn't I? So we're going to look at these later on, but make sure you understand that basic principle. Lots of times I'll put it down in the bottom or so I can work it. So again, the theory of tangent is where the radius touches that point forms a right angle. All right, let's go on to the next one. All right, it says the radius, the next one is on there, it says the radius that is perpendicular to a chord of a circle bisects the chord. Again, the radius that is perpendicular to the chord of a circle bisects the chord. All right, so let's translate that, and I'm going to change this, all right? So now I'm going to go like this. I'm going to draw a chord right here. And I'm going to reverse this here. So I'm going to reverse that. So what it does, here's my chord. My chord is AB. All right? So what this does, it divides these things into equal parts. So now I make this C here, A, C, B. So then AC, watch. AC is congruent to CB. Again, so what it's saying is, again, here's my point of tangency. I draw my radius. He says, now remember, this is parallel to this, isn't it? So if this is 90, by the way, guess what? This is what the book doesn't tell you, is when you draw this, put in a what? Got the idea? Because now you can see how we work this out. So the theorem says, he says the line, the radius bisects the chord, doesn't it? That's basically what it says. It says a radius that is perpendicular to the chord of a circle bisects it. And we know that this is perpendicular, don't we? All right, so again, if this is 5, guess what? So if that's the case, this is, you can put this down for an example. If this is 5, this is 5, isn't it? Everybody agree? Now, if that's 5 and that's 5, then guess what? So AB, correct, equals 10. So again, what it's saying is, again, I draw my chord, it's gotta be parallel to this, doesn't it? This radius bisects the chord. So this side is equal to this side. Another way of looking at it is, let's go like this. So let's say AB is 10, from here to here is 10, correct? What is AC? So again, if from here to here is 10, this has got to be half of 10, which is 5. All right, so let's review it again. It says, if this chord is basically parallel to this radius bisects the chord in 2 equal parts. So you can do it 2 different ways, can't you? Remember, this always equals this, okay? So again, I put down AC is congruent to CB, correct? And then you can look at this. This is 10, this is going to be 10. This is 5, this is 5. All right? So let's press on. All right. Now, this is basically what this whole section's doing, correct? Now, we'll go to page 575. All right? Let's see what we got here now. 575 is a great one because this is what they're going to do. It's just not going to be this simple. All right? So look at 575. It says, find the radius. It has a radius of 5, and px is 3. Now you know that's a what? Right triangle, isn't it? So I can use the Pythagorean theorem, can't I? So I can say, I can say ax squared plus 3 squared equals what? 5 squared. So ax squared equals 16, so ax equals 4. So you can go on that. So the radius is 4. This is what's important. When you're looking at these problems, the radius is always the hypotenuse. When you look at it, this you're going to have to you're going to have to draw them. Sorry, allergies are still bothering me this week. So let's look at one. And then we're going to do a whole bunch of problems, and then I'm going to send you a worksheet, okay? So here's the problem. All right? So I'm going to say this is 5, and this is 12. What is the hypotenuse? Now, quick review. If this is 12, what is this? It's 12 also, isn't it? Because it bisects it. So if that's 12, you can always throw that in, can't you? So now I got, here's a leg, and like I told you, the hypotenuse, right, is always a radius when you see it like this, because it's going from the center of the circle to here. So now I have what? 5 squared plus 12 squared equals x squared. So I bet you it's going to be 13, isn't it? So let's make sure we do it. 25 plus 144 equals x squared. 169 equals x squared. Take the square root of both sides. X equals 13. So that's how you do it, okay? So you can do these over and over and over again. It's going to be worthwhile that when I get done with the video that you may want to watch it a couple of times, because there's just a whole lot of Pythagorean theorem. Remember, this, when you see this drawn here, it's always the what? Radius. And it's always the hypotenuse, isn't it? So, use your drawings, okay? Now, turn to page 576. We're going to start doing some problems, and I'm going to demonstrate to you All right, so 576, they give you this problem here. Right? There it is, isn't it? Now, they draw out here, correct? So watch, now when they draw this out here, again, this is the right angle, isn't it? So this is a leg, and this case this is the what? Hypotenuse, isn't it? So they give you the information, it says KL is 2, and Km is 1. So this is 1, this is 2, isn't it? Hold on. No, Lm is 2, I'm sorry. So this is 2 here, isn't it? So now I know leg, so I go like this. This is a leg, this is a leg, this is a hypotenuse. So it's what? 1 squared plus x squared equals 2 squared, correct? So 1 plus x squared equals 4. I subtract 1 from both sides. So now I get x squared equals what? 3. So x is equal to the square root of 3. Strongly recommend when you do these problems on your worksheet that you draw it out so you can physically see it. All right, so let's look at this problem again. They gave you this is, the radius is 1, they give you the hypotenuse is 2, and they want you to find this section here. So it's going to be 1 squared plus x squared equals 2 squared. 1 squared plus x squared equals 2 squared is 4. Subtract 1. So x squared equals 3, take the square root, x equals the square root of 3. All right. So you're probably going to want to watch this video a couple times. And I already know Monica's thinking about questions. So Monica, I got you in mind. All right, let's go on to the next one. Okay? Now, they're going to do one upside down. Problem number 7, okay? Problem number 7 looks like this, doesn't it? And it's circle R, and they give you, it says QR. QR is 3, isn't it? It says find RS. Well, this is pretty easy because I know what? From my drawing, I know that this equals this, doesn't it? So in this case, if this is 3, what is this? 3. And you're done. That's all you got to do. Okay? Again, like I said, remember this bisects the chord, so they gave you this is 3, that's got to be 3. They could ask you what this is, correct? They could ask you what, sometimes they're going to ask you what QS is, and QS is 6, isn't it? All right? So I'm going to put down Q, and here's S, just so it looks good. So again, pretty easy, isn't it? But you got to sit down on a 3x5 and use that stuff that I gave you already. All right, problem number 8, okay? Oops. Okay, again, like I said, I love drawing pictures. I don't draw very well, but it helps you so I can fill them in. Now, if you're taking a test or a quiz, if that's the only time you use, that's fine. So let's look what number 8 looks like. And it looks like, I'm just gonna rewrite it this way. Looks pretty good. X, W, Z. This is X, that's W, that's Z. This is V, and this is Y. And they give you, it says the radius is 13. Well, they give you this, so here's your radius. So they give you this is 13. And it says XW is 5. Guess what? Same problem over again, isn't it? Pythagorean theorem. It's a 5, 12, 13 triangle, isn't it? But let's review it. So I need to find this, don't I? So now it's a Pythagorean theorem. I know that x squared plus 5 squared equals 13 squared. So x squared plus 25 equals 169. I'm going to subtract 25 from both sides. So x squared equals 144. Take the square root of both sides. Correct? And it's going to equal 12. Just redoing the practice problem over again, isn't it? So again, this is what was given. Remember, this is a leg, and hypotenuse, and we already did this problem one time, didn't we? All right, let's press on. All right, let's do number 9. It says, now number 9 says, prove that it says verify that AB is tangent to C. All right, is AB tangent to 3? If it's tangent, correct, it should form a right triangle. So again, we're going to use the Pythagorean theorem again, aren't we? And they give you this is 10, this is 8, and this is 6, right? Now, if this is a right triangle, we can use the Pythagorean theorem. We did this when we did the right triangles before. Prove it if this, okay, so now I want to say, does 6 squared plus 8 squared equal 10 squared? Because if I remember, we said if that's true, it's a right triangle. That was on one of your test and quiz. So let's see. 36 plus 64 equals 100. Guess what? 100 equals 100. So it's got to be a right triangle, and we just proved it, didn't we? Again, here's where you got to prove it. Now, if it didn't equal, if the left side didn't equal the right side, then it's not what? A right triangle, and this is not tangent, is it? Okay, so we got about 4 more problems for you guys to digest, and we'll send this out. And just think you guys thought you were done with the Pythagorean theorem, didn't you? Well, it's not going to go away. All right, let's look at problem number 10. I'm going to do all these so you can use it for your worksheet. There's only 10 problems on the worksheet. I'll send out the answers tomorrow morning. All right, so here's your drawing, right? Hope you can see that. We got this. Oh, looks like you got a diameter there. No, you don't. us, right? All right, and they say it's R, W, RX, I'm sorry. RX, W's in there, and Z's over here, isn't it? All right, so let's see what they give you. It says XW is congruent to what? So it says XW is congruent to what? Now, pretty simple problem, because we know that this divides this equally, doesn't it? So then XW has to be congruent to what? WZ. Again, this side is congruent to that side. So XW equals WZ. Let you look at that for a minute. Gee, wouldn't it be nice if your test was made up of those, huh? All right, here's why. So now I'm going to go on to problem 11. Okay? So it says RY is 7, RW is 2, RW is 2, RY is 7. So RY is 7, RW is 2. So if that's 2 and that's 7, for what it's worth, now watch. Remember, segment addition. Watch, I'm going to finish this up 21st. From here to here is 7. Everybody agree? So if this is 2, this has got to be 7 minus 2, segment addition. So again, if this from here to here is 7, and this is 2, this one's got to be what? 5, doesn't it? Correct? I'm just going to put that in there. So I know that what? WY equals 5. Watch, 5 plus 2 equals what? 7, so it's good, isn't it? So I just threw that in there. I'm not done with the problem, but I'm filling it in because I know segment addition. We haven't had that in a while, have we? It says, what is XW? I think I'm doing this right. Oh, you're not going to have this problem because they want you to know what YZ is. So guess what? You got to go like this, don't you? Got the idea? You're not going to get this on the test. Trust me. That's a problem that you won't even see on the quiz. So we're just going to overlook this one. Unless you want to do it on your own. Because I sure don't like it. Sometimes they put problems in there that just don't make a lot of sense, do they? All right. It says, look at number 13 now. Okay, 13. Now, what they're doing here is you gotta look at the deal from the 16, watch, this 16 goes from here to here. I don't like the way they do it, but if from here to here is 16, then doesn't this have to be half of 16? Because remember, this plus this equals 16, so this has to be what? 8. We know that's 6, doesn't it? Correct? So now we can do the problem. So this is 6, this is 8. They want to know what the radius is, isn't it? So guess what? It's going to be 6 squared plus 8 squared equals, it's going to be 10 again, isn't it? We already did this problem. But the trick is here, we always have problems with this. From here to here is 16. These two are equal, aren't they? So if that's 8, so is this, isn't it? And I know this is going to be 10 because we just did the problem, didn't we? 6 squared plus 8 squared equals x squared. So that's going to be 36 plus 64 equals x squared. 100 equals x squared. So x equals 10. Again, here's the one you gotta learn, is from here to here is 16, but we know these two are equal, so this is 8 and this is 8. All right. Let's do the last one. I figured out how to do that one that was missing is this. Okay, I'm going to go back to it because it could be important. All right, number 14. In the circle N, verify that line L is tangent by using the converse. Converse is, okay, this is a good problem just to show that you got to fill stuff in, okay? Correct? So watch, I'm going to go like this, correct? And we're going to go like this, and we're going to go like this. Okay? So I'm just drawing the picture. This is 3, right? This is 4, and this is 2. Now, again, watch. If this is a radius, aren't all radiuses equal? So if that's 3, guess what this is? Got it? That's why it's important. The problem is, so this makes it a 3, 4, 5 right triangle, doesn't it? So this is perpendicular, isn't it? 3, 4, 5. How many times we did 3, 4, 5? Here's the trick, right here. All radiuses are equal, aren't they? All right, I'm going to go back and do the other problem because it has something to do with this one. All right, so let's see what we got here. So I'm going to go back because that helps me solve the other problem, which you could have in the test. I'm going to go back and do this problem number 11. So again, I'm going to draw on the picture, correct? And watch, this is what's important. It says that Ry, right? Here's the trick to this problem. Ry, but isn't Ry a radius? Everybody agree? From R to Y, is that a radius? Aren't all radiuses equal? So guess what? If this is 7, this is 7, and that's 7, isn't it? That's how you solve problem number 11. And they gave you this as what? 2, didn't they? So now we can do the problem. Make sure you, in your notes, you make sure that all radiuses are what? Equal. This is an easy problem now because, right? It says find out, we know that that's 7, correct? And it says XW. We want to find out what this is, don't we? Correct? So now what we got to do is what? X squared plus 2 squared equals 7 squared. So x squared plus what? 4 equals 49. Subtract 4, and x squared equals what? Square root of 45. Now, here's one nice thing. I'm not going to split hairs and deal. You can take the square root of 45, which is going to be just a little bit less. It's going to be about 6.8 if you work it out. Or some people in the calculator are going to have this. It's going to be what? The square root of 9 times the square root of 5. So x equals 3 times the square root of 5. A lot of you people have the calculator can do that. Or you can do what? Just the square root of 45 is just about 6.8. Let's see if I've got one of these things that works. Yeah, they got, this one here brings it up to 3.5. All right, so there's all your problems. Again, I strongly recommend that, you watch this video another time, but on your worksheet you're probably gonna see all these problems, and on the test, you're probably gonna get an easier version of these, okay? I'm really thinking about giving you a test on 9.1, 9.2, and 9.3, which is a lot easier than giving you a test on 9.1 and 9.2. All right, so again, 9.3 is pretty easy. The test is a lot easier than that. So, all right, so if you got any questions, email me at rallison@ecalines.org. You got the email, and I'll hit you something back with it. Again, we're going to send out a worksheet. It's only got 10 problems on it. And then we're going to press on. Remember, if you got any questions, let me know. We're probably going to have a helps class Thursday again, because that did generate questions. All right, have a good day.